Suppose someone asked you to explain or describe this number. What would you say? How would you do it? I'd say that's 1/4, Mr. Cox. Okay, you've just read it, but that's not describing it. How about you, Irving? How would you explain this number? It could be 1/4. Is this one of those trick questions, Mr. C? No, not really. You're both correct, but there's another way to read this which describes it much better. So let's see if we can come up with some answers. Yeah, answers would be nice. I'm a little confused. First, let me list out the things that we'll be covering in this video. We will learn the basic definition of fraction numbers. We will learn what you can and can't do to fraction numbers. We will learn how to compare fractions to each other. And finally, we will learn the rules of addition, subtraction, multiplication, and division of fraction numbers. Now let's look at this fraction again. Let's see if we can explain its basic definition. Tell me again how you would read this. Well, I don't know. Like I said before, 1/4. Or 1/4. Again, those are both correct ways to read this. But there's a much better way to read this, which is much more descriptive. You can also read this as 1 part out of 4 parts. The bottom of the fraction always describes how many equal parts an object was cut into. Here it's 4. And the top of the fraction always tells you how many of those pieces you're talking about, which is 1 part in this example. 1 part out of a total of 4 parts. Now, if we're talking about 1 part out of 4 parts, how many parts of the total are we not talking about? I imagine we're not talking about 3 parts out of 4 parts. Correct. That's what's left from 1 part out of 4 parts, 3 parts out of 4 parts. And if you add the part you've started with to the part left over, 1/4 to 3/4, you get 4/4 or 1 whole unit back. Now what about the fraction 2/3? What can you tell me about that? Okay, something was cut up into 3 equal parts, and we're talking about 2 of them, or 2 parts out of 3 parts. And the part we're not talking about is 1 part out of 3 parts. And if you add these 2 fractional parts together, 2/3 to 1/3, you get 3 parts out of 3 parts, or 3/3, which equals 1 whole unit. Now that you know what you know, let me ask you a question. What if I've eaten this much of a pizza? What information does this give you? First of all, how many total pieces was the pizza cut into? It was cut into 8 equal pieces. Correct. And how many pieces have I eaten? You've eaten 3 pieces out of 8 pieces. Okay, how many pieces are left? 5 pieces are left. So what fraction of the total pizza is left? 5 pieces out of 8 pieces are 5/8. And if you add the fraction I've eaten to the fraction that's left, 3/8 to 5/8, you get 8/8, which equals 1 whole pizza. You can always read a fraction or construct a fraction if you remember that the part you're talking about always goes in the top of the fraction, and the total number of equal pieces the object was cut into goes into the bottom. Now let's see if we can construct some fractions using this basic definition. This object is divided into several equal pieces, and some of those pieces are shaded blue. What fraction of the total object is shaded blue? The total number here is 7. 3 of those pieces are blue, so the fraction of blue pieces to the total number of pieces is 3 parts out of 7 parts, or 3/7. Now what fraction of the total object is not shaded? 4 out of the original 7 parts are not shaded. So 4/7 is not shaded. Yes, and when you add the shaded portion to the unshaded portion, you get 7/7, or 1 whole unit. Here we have a number of objects where some of them are colored red. The red objects represent what fraction of the total number of objects? There's a total of 10 things here. which goes into the denominator of the fraction, and 7 of these are shaded red, which goes into the numerator of our fraction. So 7/10 of the total things here are shaded red, and 3 out of 10 are not shaded, so 3/10 of the total object is not shaded, and 7/10 plus 3/10 equals a total 10/10. Yes, how about this problem? The violet shaded pieces here represent what fraction of the total? The total number here is 9, and 4 of those are colored violet. That means that 4/9 is colored violet. 5 sections have no color, which means that 5/9 of it is not colored. And 4/9 plus 5/9 equals 9/9. Another thing you'll need to know is to be able to identify the 3 different forms of fractions. These 3 different forms are proper fractions, improper fractions, and mixed numbers. Proper fractions are where the top, or the numerator, is always smaller than the bottom, or denominator. Improper fractions are where the numerator is always larger than or equal to the denominator. Mixed numbers are simply whole numbers along with fraction numbers. Each of these forms have certain characteristics about them. For example, improper numbers can be changed into mixed numbers, and mixed numbers can be changed into improper numbers. You will need to know how to change these back and forth when multiplying and dividing fraction numbers. All proper fractions can be raised to higher numbers, and some proper fractions can be reduced. There will be times when you have to raise a fraction up or reduce a fraction to its lowest form, if it has a common divisor in both the top and bottom numbers. Let's first discuss the rules of raising and reducing fractions, then we'll look at changing mixed numbers and improper fractions back and forth into each other. There will be times when you'll have to raise the denominators of fractions up in order to add or subtract them, so we'll have to learn the rules of raising fractions. Let's take an example to better explain this. Let's say I want to take the fraction 3/4 and raise the bottom up so that it's now 20. What we now have to do is find the top of the new fraction, and here's how we do this. We have to ask ourselves, what number did we multiply 4 by in our original fraction to get 20? You multiply 4 by 5 to get 20, Mr. Cox. Yes, so if we multiply the bottom of our fraction by 5, we must also multiply the top of our fraction by 5, and the top of our raised fraction becomes 15. Now let's change this fraction so the bottom of the raised fraction is 32. Let me try this one. Okay. You have to figure out what you multiplied 8 by to get 32. Then multiply the top by that same number. So what's the multiplier? You multiplied 8 by 4 to get 32. So you have to multiply 7 by 4 to get 28 for the top of the raised fraction. That's correct. One of the basic rules of fractions is that whenever you change the top or bottom of a fraction by a certain multiplier, you must change the other number by the same multiplier. Can you raise fractions to any numbers you want, Mr. Cox? That's a good question. Let's look at the 2 fractions we just raised up. Look at 3/4 again. Would it be a good idea to try and raise the bottom of this fraction to a number like 11? Well, no. Why not? There is no whole number you can multiply 4 by to get 11. That's right. It is possible to change fractions to any numbers you want, but we're going to stick with whole number multipliers here. So what would be some good choices to raise this fraction to? I guess that any number that 4 divides into evenly would be good, like 8, 12, 16, 20, 24, 28, and so on. And the numerators to these raised fractions would be 6, 9, 12, 15, 18, and 21. Yes, there are many numbers you can raise this fraction to, but for our purposes we're going to stick with whole number multiples. How about 5/7? What would be some good choices to raise this fraction to? Some numbers that 7 divide evenly into are 14, 21, 28, 35, 42, and 49. Those would be some good choices. And the tops of those corresponding numerators would be 10, 15, 20, 25, 30, and 35. Yes, any whole number multiple of 7 would work. And remember to change the top number by the same multiple as you change the bottom number by. Let's take one more example. Let's say I wanted to raise 4/5 so that the bottom is 25. What do I have to do to find the top? You must figure out what you multiplied 5 by to get 25. The multiplier here is 5, so you must multiply the numerator by 5 to get 20. So 4/5 can be raised to 20 25ths. That's correct. What would be some other good choices to raise 4/5 to? Some good choices would be 10, 15, 20, 25, 30, 35, and so on. The corresponding tops of these fractions would be 8, 12, 16, 20, 24, 28, and so on. Well done. Now let's see if we can figure out the rules for reducing fractions. Now let's talk about reducing fractions or making fractions smaller. But before we start, let me make a point about basic arithmetic. You must be able to do basic multiplication and division of whole numbers well in order to understand fraction arithmetic. For example, you must know things like, what are all the numbers that divide evenly into 6? 1, 2, 3, and 6 divide evenly into 6. And what about 12? What are all the numbers that divide evenly into 12, Irving? Let me see. 1, 2, 3, 4, 6, and 12. Yes, that's correct. So if you're weak in basic arithmetic, I would strongly recommend that you practice multiplication and division of whole numbers so that you'll be able to do the fraction arithmetic. For example, you'll have to know things such as, what are the multiples of the number 6? 2 times 3 and 6 times 1 are multiples of 6. What are the multiples of 12? 2 times 6, 3 times 4, and 12 times 1 are the multiples of 12. What are the multiples of 7? Well, just 7 times 1. So if you're weak in basic arithmetic, I would strongly recommend that you practice multiplication and division of whole numbers so that you'll be able to do the fraction arithmetic. Now let's look at reducing fractions. First, I want to put up a fraction on the board, then ask you a question. Can this fraction be reduced or made smaller? And if so, what is the answer? Yes, it can. And the answer is 3/4. Okay, tell us what you did to get that answer. I divided the top and the bottom of the fraction by the common divisor of 3 to get 3/4. Yes, what you may not realize is that mentally you had to ask yourself if the numbers 9 and 12 had a common number that you could divide out. In this fraction, both 9 and 12 could be divided evenly by the number 3, so you could reduce it by dividing the numerator and the denominator by 3. What if you couldn't see that common number right away? Is there a way to find it if it exists? I don't know, Mr. C. Is there? Yes, let me show you how. Look at 9/12 again. Look at the top number and list out all the numbers that divide evenly into 9. Now list out all the numbers that divide evenly into 12, and make sure you list them all. 2, 3, 4, 6, and 12 all divide evenly into 12. 1 can also be divided into these numbers, but we'll ignore that number for now. Now look to see if you have a common number top and bottom. Yes, 3 is a common number in both of them. Correct. So both the numerator and denominator can be divided by 3 to get the reduced fraction 3/4. Let's take another example. Can the fraction 14/28 be reduced? I want you to list out all the numbers that divide evenly into 14 and all the numbers that divide evenly into 28, then see if they have any common numbers. 2, 7, and 14 divide evenly into 14. 2, 4, 7, 14, and 28 divide evenly into 28. Okay, as you can see, these numbers have three common numbers, 2, 7, and 14. So which one do we use? You'll always want to use the largest number, because if you don't, you have to keep reducing it until you get to its smallest form. So you divide the numerator and the denominator by 14 to get 1/2. Correct. How about this fraction? 25/30. Can it be reduced? Let's see. 5 and 25 are all the numbers that divide evenly into 25. And 2, 3, 5, 6, 10, 15, and 30 are all the numbers that divide evenly into 30. Both 25 and 30 have the common divisor 5, so we can reduce the top and the bottom of 25/30 by 5 to get the reduced fraction 5/6. Yes, as you can see, 30 had quite a few numbers that will divide evenly into it, and it was your job to make sure you knew all of those numbers in order to be able to reduce it to its lowest terms. Let's take another example, 48/64. Now these are large numbers, and it wouldn't be a good idea to start listing all the numbers that go evenly into these two numbers. Ideally, you want to try and find the largest number that you can divide out and do it in one step. But if that's not possible, find any number that is common and start with it first. I know that 8 goes into 48 and 64 evenly, and that leaves 6/8. That's correct. Is this answer in its lowest form? No, it can still be reduced by 2 to get 3/4. The largest common number here is 16. 16 divides into 48 3 times, and 16 divides into 64 4 times. As you can see, you can always reduce fractions in steps if you're not able to find the largest common divisor right off the bat. You'll always get to the lowest form if you keep reducing. Now let me ask you a question. Can 9/16 be reduced? If so, what's the answer? If not, tell me why. Let me think. Well, no, it can't be reduced. That's right. Now explain to me why it can't be reduced, Irving. 3 and 9 are all the numbers that divide evenly into 9. And 2, 4, 8, and 16 are all the numbers that divide evenly into 16. And as you can plainly see, there are no common numbers that will divide evenly into 9 and 16. So 9/16 is already in its smallest form. That's correct. Now let's talk about improper and mixed numbers. Another thing you'll need to know in order to do fraction arithmetic is to be able to change improper fractions to mixed numbers and mixed numbers back to improper fractions. Let's look at this example, 9/5. You can see that this is an improper fraction because the numerator is larger than the denominator. In order to change this fraction to a mixed number, you have to do some work, some arithmetic operation. Like what, Mr. C? Let me first ask you a question. What is this word? Why, that's record. No, that's record, isn't it? As you can see, this word has two distinct different meanings depending on the context in which you're using it in. It could be the noun record or the verb record. So it has two distinct different meanings depending on the context you're using it in. There are also math objects that can be interpreted more than one way. This object can be interpreted as a fraction, 9 parts out of 5 parts, or it can be interpreted as a division problem, 9 divided by 5. So this line has two different meanings depending on the context you're using it in. If you want to change this number into another form, you must perform division, and here's how you do that. First, you draw the division house alongside the bottom number, and picture tilting the fraction so that the top number can slide off into the division house. As you can see, the denominator always goes on the outside, and the numerator always goes on the inside. It will never be the other way around. So remember this technique in order to remember the order in which they go. Now perform regular division. 5 divides into 9 at most one time with a remainder of 4. You write this remainder as a fraction, 4 over your divisor, 5. So that 9/5 can be changed into the mixed number 1 4/5. Remember, if we read the improper fraction as 9 parts out of 5 parts, now it has meaning. Something was cut into 5 equal parts, and we took 9 of them. In order to get 9 parts when the object is cut into 5 equal parts, we have to cut another object into 5 parts and take 4 more of them. So as you can see, we have one whole object and 4/5 more of another object. How would you change the improper fraction 15/4 into a mixed number, Irving? You rewrite it as a division problem. 15 divided by 4. Next, 4 divides at most 3 times into 15 with a remainder of 3. You write that remainder as a fraction 3/4. So 15/4 can be rewritten as the mixed number 3 3/4. What about the fraction 20 over 6, Bruno? 6 divides into 20 at most 3 times, which leaves a remainder of 2. You write that remainder as the fraction 2/6. 20 over 6 can be rewritten as a mixed fraction 3 2/6. But is this fraction part in its smallest form? No, it can be reduced top and bottom by the common number 2, which leaves 1/3. Yes, 20 over 6 can be rewritten as 3 1/3. One more problem. Change 25/5 into a mixed number. 5 divides into 25 exactly 5 times with no remainder. So 25/5 is 5 with no fraction part left over. Yes. Now let's change mixed numbers into improper fractions. Let's look at the fraction 2 3/4. Here are the steps necessary to change this into an improper number. The bottom remains the same, and the way you find the top of the fraction is that you multiply the denominator times the whole number, then add the numerator to that number. Here, 4 times 2 is 8, then you add 3 to that to get 11. So 2 3/4 can be rewritten as the improper fraction 11/4. Bruno, change 5 7/8 into an improper fraction. The bottom remains 8. You multiply the denominator of the fraction, 8, times the whole number, 5, to get 40. Then add 7 to that to get 47. So the answer is 47/8. Let's look at one more example before we move on to the next section. How would you change 10 and 8/9 to an improper fraction, Irving? Well, the denominator of the improper fraction will be the same as our mixed number, which is 9. Then to find the top of the improper fraction, we multiply 9 times 10 to get 90, then add 90 to 8 to get 98. Before we learn the rules of addition, subtraction, multiplication, and division of fractions, there's one more concept we should talk about, which is fraction size and comparing fractions to each other. If you have fractional parts that are in fifths, how many fifths can you have between 0 and 1? 1, 2, 3, 4, and 5. What if you have fractional parts in sevenths? How many fractional parts can you have between 0 and 1? 1, 2, 3, 4, 5, 6, and 7. When the bottoms of fractions are the same, it's easy to tell which is larger. For example, 3/5 is larger than 2/5. Just compare the tops. 3 parts out of 5 parts is more than 2 parts out of 5 parts. In sevenths, 5/7 is more than 4/7. When the bottoms of fractions are the same, it's easy to tell which is larger. Just compare the tops. But what if you're comparing fractions that have different denominators? What do you do then? For example, which of these two fractions is larger, 3/4 or 4/5? 3 parts out of 4 parts, or 4 parts out of 5 parts?
3/4?
No, isn't 4/5 larger? I can see we have a discrepancy here. If the bottoms of both of these fractions were the same, we could just compare the tops to see which fraction is larger. Remember the previous section where we raised fractions to higher numbers?
Yep, I remember. Me too, Mr. Cox.
You know that we can raise 3/4 to 8ths, 12ths, 16, 20ths, 24ths, and so on. The corresponding tops of these would be 6, 9, 12, 15, 18. And we can raise a fraction 4/5 to 10ths, 15ths, 20ths, 25ths, and so on. And the corresponding tops to these would be 8, 12, 16, and 20.
Now what, Mr. C?
Now we look to see if we can find fractions in the top row and the bottom row that have the same bottom number or denominator.
The place where they both have the same denominators is in the 20th place. 3/4 can be raised to 15/20, and 4/5 can be raised to 16/20.
Yes, now let's focus on these two numbers. You know that 3/4 can be raised to 15/20, and 4/5 can be raised to 16/20. Now that we have equal bottoms in each fraction, we can just compare the tops. Which is bigger, 15 parts out of 20 parts or 16 parts out of 20 parts?
Well, 16 parts out of 20 parts is larger.
That means our original fraction, 4/5, is larger than 3/4.
Isn't there an easier way to do this besides just raising both fractions up until the bottoms are equal?
Yes, there is. If you look at what I did here, I raised each of these fractions up to the first number that both 4 and 5 will divide into evenly. Now 20 is the first number that both 4 and 5 will divide into evenly, but it's not the only one. 40 will work, 60 will work, 80 will work, and so on. But 20 is the smallest number that both 4 and 5 will divide into evenly. The object is to raise the bottoms of the fractions you're comparing up to a common denominator that both your starting denominators will divide into evenly. Then you find the tops of the new raised fractions and compare them. Let me now explain the steps on how to find the first number that all denominators will divide into evenly. First, we have to have a starting number, so we always start with the largest denominator. Here 5 is a larger number, so we take that number out to the side and ask ourselves if 4 will divide evenly into 5. No, it won't. So here's what we do next. We take another 5 and add it to our original number to get 10. Then we stop and ask ourselves if 4 will divide evenly into 10. No, it won't. So we take another 5 and add it to the 10 to get 15 and ask ourselves if 4 will divide evenly into 15. Again, no, it won't.
So let me guess. We take another 5 and add it to the 15 to get 20. Then ask ourselves if 4 will divide into 20. And yes, it will.
That's correct. Like I mentioned earlier, 20 is not the only number 4 and 5 will divide into evenly. 40 will work, 60 will work, but 20 is the smallest number that 4 and 5 will divide into evenly, and you'll always want to use the smallest number you can find. Next, we have to raise each of these fractions to 20ths, which means we have to find the top of each one. Do you remember how to find the tops of raised fractions, Bruno?
I certainly do. If you're going to raise 3/4 to 20ths, you have to figure out what you multiplied the denominator by to change the numerator by the same multiplier. You had to multiply 4 by 5 to get 20, so you must multiply 3 by 5 also to get 15. In the lower fraction, you had to multiply 5 by 4 to get 20. So the numerator is 4 times 4, or 16. Now we just compare the numerators of the raised fractions to see which one is larger. 16 is larger than 15, so our original fraction, 4/5, is larger than 3/4.
Well done. Now what if I wanted to compare 5/8 and 7/12 to see which is larger? What do we have to do first?
The bottoms have to be the same first before we can compare them.
Correct. So how would you find the first common denominator?
You'd start with the larger of the two numbers, which is 12, and ask yourself if 8 will divide evenly into 12. No, it won't. So you add 12 to itself and ask yourself if 8 will divide evenly into 24. And yes, it will. So the first number 8 and 12 divide evenly into is 24.
Yes, what next?